The information I'm going to give you may fundamentally change how you think about agentic coding. Because getting better results from these tools like Claude Code and Codex is not just about using smarter models and using better prompts. It's all about the systems that you build around these tools. And once you understand better systems, such as managing context, delegating tasks with subagents, or having harnesses or skills in place to make your output even higher quality, you'll stop thinking about these tools as simple chatbots and instead as an actual engineering workforce that you can use at your disposal. Now, if we were to look at these statistics, almost 90% of developers are using AI tools, which is increasing every year, but only 29% of them actually trust the output. So there is a fundamental issue with using these tools, but using good structures around them can actually increase the output and give you more confidence that what they're producing is of higher quality. And you can also see over here, Codex and Claude Code is still growing. 1 in 5 people using Codex aren't even developers. So people who have no coding experience are able to vibe code entire applications, which if you are a vibe coder, this talk will also be very relevant to you. So let's move on to talking about the core loop that all these harnesses basically follow. So if you want the best output from these tools, you should probably follow a similar type of structure. And honestly, most of these tools probably do this for you without you thinking about it. And the output of these harnesses are getting better over time. But out of all the cool features and all these different harnesses, the thing that you should focus most on is how to manage the context window. The models are built with limitations. They do have a cap of how much information you can provide them. And as that context window fills up, they will become less and less intelligent. Luckily, we have ways to delegate subagents so that the context windows stay short and fresh. Also, making sure that you don't prompt too much at a time and clearing the window is another strategy that you can do. But overall, if you're trying to add in like a new feature or build out an application, here are the 5 steps that you should be taking to make sure that the output and the structures around your harnesses and your models are actually high quality. So the first step is you should be delegating subagents or even just using a plan mode to go off and find as much relevant information in your code base. Maybe it needs to read over documentation files or go read your agents MD, or maybe you have skills that are set up. It needs to go off and explore, and the more subagents you have doing this, the faster it can kind of give back relevant results. You don't want to pollute the context window with a bunch of unnecessary information, which is why subagents can kind of keep the context window as lean as possible. After you let the harness explore, you can go and then create a plan. This could be creating an MD file. This could be multiple MD files split up into different phases. And for each phase, you can have different tasks. This allows replayability. If your computer were to crash, you can come back and resume the session and even have different models work on different tasks at the same time. So planning, obviously, if you're using Claude Code, it has a plan mode built into it. Some people like to do their own approach and have their own MD files. Now, the key takeaway with the plan mode is that you should be reviewing the plan. If you are technical, if you're an engineer, you should review it for technical decisions so that you can tweak the plan to meet the needs of your business or your product. But if you're a vibe coder and you're not technical, you should be reviewing the plans for at least business decisions, product decisions. Should the button be over there? When you click it, what should it do, right? These are things that should be included in the plan, and you need to have some type of control to make those decisions about where your product's going. Granted, the models can basically plan it all out. They can design the system for you. They can pick the best design if you let it. They can pick the best user experience if you let it and you provide it enough skills to do so. But at least trying to be in the loop a little bit, having a human in the loop, can make the outputs that much better so that you don't have to go back and reprompt because you didn't fully understand the plan of what the model is about to build. And now you have to go back and reiterate, burn through tokens, waste more time. The third step of this loop is the implementation stages. So this is kicking off many subagents to go off and work on smaller parts of the code base. Often if you're building out an API endpoint, why does the context window need to know about the front end in that scenario, right? Maybe it needs to know about some type of interface. They can share communication across that interface or adapter, but you can have subagents go off and build out the different parts of the system so you can increase the throughput and not have to wait as long. The more subagents you can use, typically the faster this will run. Now, granted, Claude Code has something called workflows, dynamic workflows, which kind of does all this for you. This is why they added this feature. They have a system that basically does all this for you. And if you're not going to build your own type of core loop, you should probably just leverage the harnesses loop because they kind of done the heavy thinking up front for you to get the stuff to be as accurate as possible. Now, the fourth step, this is by far the most important. This is the verify step. You should have these agents run end-to-end tests. They should load up Puppeteer. They should load up a browser. They should be clicking through the UI and verifying that what they're doing is actually accurate. And often in this stage, the verify stage, you'll see it go back and fix. Like it basically, if you imagine there's a loop here, it's going to go and verify and then go back and implement, go back and verify, go back and implement. And you can take the verify stages as far as you want to. You can give it API keys for your deployed staging environment. And you can say, hey, get this deployed out to a staging environment. I want you to go then get a browser and click through it, make sure it's all set up, make sure the database is actually persisting properly and reading back values. The more robust your verify stages are, the better it's going to be. You can also have agents, other models come through and verify. So if you're working with Claude Code or let's say Fable 5, you can then have Sol, GPT 5.6 Sol, go back and verify all the work that Fable did. And again, you can just do this in a loop. Depending on how much money you have, how thick your wallet is, you can have these agents and burn through tokens to verify, to re-implement, to redesign, to check for security audits, to check for performance issues, to make sure the code is clean and clear and concise. These are all things you can add in with skills to actually go through and make sure the code is the highest quality as possible. Now, the last step is committing. You should be committing, or at least telling the agents to commit small chunks of work every step of the way. These commits have useful history inside the commit message, and they can let the agent go back in time and try to understand and debug how the system has changed over time. Typically, I just use Git as my memory system. Git has all of the changes, and if you let the AI commit really useful, concise messages of why we changed the thing, this is the change. If you run into a bug in the future, it can use a git bisect. It can go back and dive through the changes and try to figure out where exactly it broke that particular thing. Or maybe it was an actual business change that you made that can be documented in commits, or you can just have those be documented in like a memory MD file. You can have these agents also build out architectural design decisions, and it can put that in a folder so that later on you could have a Claude MD file or an Agents MD file reference those to say, hey, before you add in any code to the code base, make sure you go and look at the decisions we made in the architectural design records, so that in the future it doesn't maybe change the design, or it understands with more context how it all works. Now, you can also hook in your loop to actually go and look at GitHub issues. Often a lot of teams will use GitHub issues to define the user stories and what needs to be done, the acceptance criteria, and you can link the stories with the pull requests with a tag, like an ID. And then you can also have that ID be in the commits. So the more information you can give in terms of your commits, your GitHub issues, your pull request, it allows your agents to go and explore your code base and find the relevant context. So this is the loop that honestly, a lot of this is abstracted away from you at this point, but understanding how it kind of works under the hood is extremely important to become the best agentic coder that you can be. All right, so let's move on to the next section, which is the Claude MD and the Agents MD file. You've probably heard about this. There is some difference in opinions on if these are useful or not. I think these are very useful. But you need to make sure that they're clean and concise. Do not let AI generate these things. You should just go through and add small bullet points of what exactly you want the agents to understand when they're building on this code base. A lot of the times, these agents are smart enough now to go and explore your package JSON file to understand what scripts it can run off the bat. But if there's any edge cases or caveats you should point, maybe put that in your Claude MD file, right? For example, if you want to make sure that all work that's done from an agent does test-driven development, you should put that in the Claude MD to say, hey, do test-driven development. Make sure you have unit tests, integration tests, and end-to-end tests written before you actually start implementing the code changes or the fixes. You can define how the commit messages should look here. So you can say every commit message must have a GitHub issue in the commit. All pull requests must have that GitHub issue number. Any new GitHub issues that the agents create must follow a certain pattern. Now, just keep in mind that these files, if you have too much information in them, they are going to fill up your context window. And so I would keep these lean and concise so that every single agent that runs on your code base follows a very similar approach. For example, what you can put in here is your exact build, test, and link commands, which even this is a little bit too much. It can read the package JSON and understand how to do this stuff. But like I mentioned, you can do code styles in here. You can do repo etiquette, branch naming, PR conventions, architectural decisions. So going back to the ADRs I talked about, you can have in the Claude MD a link to your ADR docs file so that every time before the agent starts planning or exploring the code base, it knows that you have a whole list of documents that explains why you're using Postgres, why are you using this for your queuing mechanism, why are you deploying this stuff to AWS RDS, right? These things help guide the agents so they can become a lot more accurate with the output that they're making. Okay, this one's important. Mistakes the agent made before, log so that they don't repeat. Now, some people use like a memory.md file, and most of these harnesses have memories built in, but you could have a skill that automatically runs at the end of every session to summarize the things that it messed up on and put that in an MD file and link to it from the Claude MD or the Agents MD so that next time when you do something in the agent, it's not going to repeat that same silly mistake. One thing that I've seen for certain when you're kind of using these tools is if you read through the output as they're running, you will see that they will consistently make very similar mistakes. And unless you have a system in place to let it learn from these mistakes, it'll just keep on making them. Okay. So I recommend using these, but keep them clean, keep them concise. Don't let AI just automatically generate a 5,000 line agents MD file. Put the things that you want to direct the agents in this, and that's it. All right, the third important thing to talk about is the plan mode. And like I mentioned with the core loop, plan mode typically will go off and explore your code base with subagents. So it kind of takes care of that, and it'll come back and it'll generate a plan for you that you should review. If you're a vibe coding, you should still review the plan. You can have the agent summarize it and be less technical if you want. But I think the true benefit of the plan mode is that often it starts to ask you questions, right? If you ask for a very simple feature like, hey, I want you to add in a way for users to export all their data from my application, there could be 5 or 6 other questions that it needs to ask you. What format should the export be in? Should it be in a CSV? Should it be a zip file? These are things that sometimes you don't think about until you kick off a plan mode, and then the agent will guide you to build out a better user experience, plan out a better architecture, because let's say you have gigabytes of data. You can't just put that all in a zip. You have to do that in a worker, which means you might need an SQS queue or some type of queuing system in a background worker to even handle all that data. What if the user decides to click that button and spam your system, and it keeps grabbing 10 gigabytes of data and putting that in a zip, and then after 100 runs, it crashes your services? These are things that you sometimes don't think about, especially if you're a vibe coder and you're not technical, that the plan mode can potentially help with. And honestly, when you're planning out, you should probably have some type of MD file that helps guide you through these performance decisions, the technical decisions, also the user experience decisions, the business requirements. Because often if you just give a very simple sentence of, hey, I need the ability to export data, you're going to miss 8 or 9 different really important things that you didn't think about. Now, another reason you should be using plan modes is because once you kick off that plan and tell these agents to go off and implement it, this can take a long time. This can take hours. And so if you let this plan be implemented for 4 or 5 hours and you come back and realize, oh crap, I didn't properly describe what I wanted, now you just burn through a ton of API tokens or AI tokens. And now you just wasted a bunch of time. And if you just take the due diligence up front to verify the plan, make sure it seems like it's good, even have other agents review the plan is a good strategy. Sometimes I'll make the plan in Claude Code. I'll have Codex go back and review the plan. And then I'll have one more pass through with like another agent to go make sure the plan is as thorough as possible. Because once you kick this thing off, like I mentioned, it's going to burn through a lot of tokens. So let's take a quick peek at this graph. So this graph is basically showing you the larger the feature is and the more decisions that the AI makes for you, often the higher the chance that it's going to get it wrong, right? So if you have a feature that's 20 decisions, like I mentioned, how is the export format? Where is this exporter going to run? Is it in a worker? Do you want it to run in the API? If you don't clarify those decisions and really think through them, there is a much lower chance that it's going to get the stuff right. If it's a really simple feature, like let's say it's only 2 or 3 decisions, the chance of it actually building what you want is much higher. So you should think about this. If the feature you're adding in is huge, you need to spend more time up front planning it. If the feature you're adding in is very small and simple, you might not even need a plan. You can just kick off a single prompt, no plan mode, YOLO it, and it's going to implement probably what you want 100%, 95%, or 90% of the time. Now, from my research, it's saying that about 80% of your time should be spent upfront on the plan mode, and then 20% should be supervising the execution, okay? And like this chart kind of demonstrates, the more time you spend upfront in the plan, the better the outputs and the results are going to be. Okay, a good strategy is to have the agent interview you so it can ask you a bunch of questions. There's skills out there like Matt Pocock's Grill Me skill. This is basically what it's saying. Most people do not think about all these edge cases before they start building out the feature. Having the agents ask you question after question after question so it has a really clear understanding of what you want built. This is one of the keys to having better outputs from these harnesses and agents. All right, so let's move on to skills. Skills are very important. These are things you can add into your Claude Code instance to basically teach it how to do new things. These models are trained with a certain subset of data, and that data has a particular cutoff. It could have been cut off a year ago. So if there's a new service that you're working with, these models may have no context of how that service works. They might not know how to use the API, etc. So one thing you can do is create a skill file and put it in your .claude folder, so that when Claude runs and you prompt it, hey, I need you to connect to this API and do something, it can actually learn about how to exactly talk to that API. Granted, there are other approaches too. You can just give it the documentation of the API, and it could probably figure that, give it the Swagger docs, give it some type of schema, and it could probably understand how to connect to the API. But the cool thing about skills is something called progressive disclosure. So you have all these skill files in your project, and basically they will only kick in when you say certain keywords, right? Let's say you're working with a service called Fleet. If in your prompt you say, I need you to connect to the Fleet API, that's when it'll go and kick in the skill with progressive disclosure and then pull all that information into your context window. Like I mentioned at the very start, the context window and managing context is very important. So you don't want these things to be included in every single prompt. You want these harnesses to pull them in only when they're needed to keep the context window very slim and clean. So I want to point something out that's kind of important with this table. As you can tell, using an MCP server is going to burn through a ton of extra tokens every single session. The way it works behind the scenes is MCP is going to automatically inject its information into your context window so that the agent knows it can call certain tools. Now, the issue with this is it burns through a lot more tokens. It fills up your context window. So skills came out to try to mitigate that issue. And now the skills are only invoked when they're needed. And you typically have something called front matter in the skill. It's like a little header at the top of the file that describes when the skill should kick in. Or as a agentic operator, you can just tag it, right? You can just tag the skill and say, hey, use this skill. I need you to go and figure out how to interact with this API. So when do you use a skill? A skill is very useful when you want some type of repeatable pipeline. So I have a skill that I use that basically is a complete workflow of from planning to implementation to auditing. I kick it off every single prompt. It's called my ship skill. I say use the ship skill, and that's going to go off and kick off a bunch of different things to make sure that the code that's being written by Claude Code and Codex is of a higher quality. I tell it to look for security issues. I tell it to look for performance issues. I tell it to make sure that stuff is cleanly decoupled. We have adapters and interfaces, stuff like that. So if you want a repeatable approach to how the agent should work, you can provide the skill and then invoke it when you need it. Because sometimes you don't need it. Sometimes you just want to make a simple little UI tweak. Why would it need to go through and do a security audit and a performance audit for a simple little text change in the UI, right? So now some other good things to point out about how teams use skills is that they're version controlled. So you can have a skill that's shared amongst your whole organization, your whole team, so that you can all have a standard way of interacting with different tools or have a standard output of how these agents kind of work. Like I mentioned, my skill, if you install it, it's going to go ahead and try to make the quality and the output of your code much higher. All right, let's scroll down to module 5. So this is subagents and parallel fleets. So you've probably seen this when you prompt Claude Code. At the bottom, it's going to say it's running a certain subagent to go explore your code base, right? Now you can have different custom agents. You can have a test writer subagent that's really smart at how to write tests, how to run those tests, how to verify those tests against your code base. You can have a research agent. It knows how to go online and find stuff and aggregate that together and give it back to the orchestrator. And then the orchestrator can have a plan agent that really knows how to write plans that match your type of output. For example, let's say you're a vibe coder. You don't want all this technical jumbo in the plan. You just want like a high level overview at the bottom of what you need to read. You can have your own agent that customizes how the plan actually looks like when it writes it out. Now, the benefit of this is that the agents all get their own context window. So you can feed it a bunch of information from the orchestrator directly into the agent. The agent can go and explore and read in files and do different things. And then finally, it's going to give a summary at the very end, which will go back to the orchestrator, and the orchestrator can decide what to do with that small summary to kick off more subagents to do more work. Now, one great use case of subagents is to make the work run faster. Instead of just having one session window go through and implement all these different file changes, you can kick off 10 or 20 subagents going through your code base, modifying the code concurrently, and then when it's all done, you can come back and then kick off more subagents to go off and do code reviews or code audits, etc., and keep going back and forth between that. Now, one of the key unlocks to subagents, like I mentioned, is concurrency. And if you were to use Git work trees, you can have many different orchestrators working on different subtrees, kicking off many different subagents on those work trees, so you can get 5 or 10 tasks done at the same time. If you don't know what a Git work tree is, basically it's a complete clone of your code base. It's put into a directory, and then you can have Claude Code work on that work tree. So like, let's say you run into a bug when you're kind of clicking through the UI, you can kick off a quick prompt and say, hey, I need you to do some work on a work tree to fix this bug. It's going to kick all that off. It's not going to modify the existing context window of your orchestrator session. It's going to do that work in a work tree. It's going to use subagents to keep the context windows clean. It's going to get the work done. You can prompt it to make a pull request when it's done, and then you can have other systems in place to review the pull requests. Finally, you can have that be merged in by a human or even AI merge it in when it's verified that it's actually good. But some of the cool things that we're seeing today are like sub-agent teams, the dynamic workflows. I'm sure you've tried this in Claude Code, where a lot of the things you don't even need to think about at this point. Like the harnesses will take care of this. They will kick off many different sub-agents. They'll have specific sub-agents that are good at doing different things. And honestly, the models are smart enough where they know what a good senior engineer is, right? It can find the context that's needed to make the output of the agents be better. All right, let's talk about effort dials. This is very important when it comes to using these models because it's a lot of information. You have Claude Code, it has low, medium, high, extra high, max. It has the workflows. You have Codex, it has Sol, it has Luna, it has, Terra. There's a lot of stuff going on, a lot of different models. Every model has different reasoning, effort levels. Which one do you pick? Now, this is a hard one to answer because if you had an infinite amount of budget, like if tokens were free, I would say use extra high for everything you do. Literally everything you do. And the reason I recommend that is because when you start trying to use like a medium because you're trying to save on some token costs, basically what happens is if there's a chance that it's going to get the thing wrong, you end up spending more time and more money reprompting it, wasting time letting it run and try to fix what it messed up on. So the only time I probably drop into lower effort modes is if I want it to run a little bit faster. Let's say I just want it to run a really quick CLI command to spin up my service. Maybe I'll drop into medium or low and say, hey, just run my app. And that's going to spend less time thinking and more time just doing the work. But for most work or bug fixes, honestly, my best opinion to you guys is just keep it on extra high. If you're using Claude Code with Opus 4.8, I always keep it on extra high. If you're using Fable 5, maybe keep it on high, because like I mentioned, there is a trade-off with the effort levels. And how it works behind the scenes is that there's an allocation, like there's like a max limit of how many tokens can go into thinking. So as you use a higher level, it's going to spend more time and more tokens thinking about the work before it actually starts doing the work. I guess another thing I could recommend trying, if you're new into AI coding and agentic coding, try doing the work with low effort on everything. Just try it with low. You'll start to see how it's messing up stuff. It's like edge cases are getting missed. There's bugs that it didn't fix. Now try on medium. You'll notice that, okay, it did a much better job, but it cost a decent amount more money. And then try high and try extra high just as an experiment. But if you just want to kind of like, screw it, I just want like stuff, I want good outputs, probably just use a higher reasoning effort level. I found that even for like small UI tweaks, I've tried lower effort levels and it still like doesn't fix it. And then I reprompt it again, it can't fix it. I switch it to an extra high effort level and it fixes it. So just from experience myself, I don't even mess with the low effort levels. I just don't think it's worth your time. You're going to end up reprompting and trying to fix it multiple times. So module 7, this is the verification loops in test-driven development and deterministic guardrails. This is by far, out of all the things I've talked about, if you're trying to do autonomous coding and you want to make sure that the code is actually working before you go and load up your local web browser to test it, you need to have good guardrails in place to basically try to write tests, let the agent implement the code, run the tests, and then the agent will basically self-heal and try to fix the mistakes that it's going to make. Without a doubt, it doesn't matter what effort level you're on. These agents will churn out bad code, broken code, buggy code. But having the verification loops in place to make it go back and double and triple and quadruple check its changes will make the output much better when you come around and actually test it manually yourself. Now, one of the ways you can kick this in is by saying run the test after implementing. Now, I like to use a goal, like in Claude Code, you can say /goal, and I will say continue to run the test until everything is passing, okay? Give it a goal condition. Tell it to run the test. Tell it to go through and audit the code. The adversarial reviewer, this is also very good where it tries to find reasons as why the code it wrote is bad. It should go through the code, it should nitpick it, it should say, no, this architecture is bad, so that you can at least have more agents understanding the code that's being written and really challenge it, because a lot of these agents and models are very agreeable. They think that what they're doing is 100% correct. You go back and say, hey, you're doing this wrong. They're like, oh yeah, by the way, yeah, I messed up. So the more models and agents you have basically reviewing and picking apart the code changes, the higher quality output will be at the end by the time you come around and review the pull requests if you're a developer or technical, or just if you want to load it up locally and click around. The worst is when you spend 2 or 3 hours waiting for these things to finish and you load up the UI and it's just broken. And you're like, okay, AI sucks. No, it's because you don't have proper guardrails in place to verify the code that's being written is actually good. So module 8 is Headless CI and the autonomy ladder. So like I mentioned, when these agents are done running, they can create pull requests. You should probably have some system in place to see when a new pull request is opened up. It should go through and do one more review on all the code to make sure that it doesn't have particular issues. And the way you do this is by using the headless mode. So Claude Code, Codex, all these harnesses have a headless mode option where you can just run it with a prompt. And so if you're using CI/CD like GitHub Actions, you can just write a custom script to review the code changes using a Claude headless mode, just to give that one extra certainty. But honestly, I think that if you are just better at doing all these checks while you're coding, you don't even need the whole pull request. Unless you're working with a team of other engineers and you still have some engineers who are like manually coding, which is honestly, a lot of people are still manually coding. There's some people still copying and pasting code from the Claude web into their IDE. If you're watching this, you're probably ahead of the game. Like you're probably at the tip of the iceberg of agentic coding, because there's a ton of engineers who do not touch this stuff. They don't care about this stuff, but they will eventually need to care about this. There's really not much I want to talk about here. I mean, like you can basically have, with the headless mode, you can have autonomous agents running nonstop, reviewing code. You can have a product owner agent who goes through and tries to understand what you should add next to your product. And then you can have that hook into a GitHub action to automatically pull that issue and work on it. And then it can make a pull request. You can have a headless runner go and review the pull request. And then that can trigger more agents to go through and open up a sandbox to run the code in, verify it with real tests. It can load up a preview URL that you as the developer can click into, and you don't even have to run this stuff locally. This could all be in the cloud at this point. You can verify all the results in the cloud and then click a button to merge it into main and it gets deployed out. Okay, so pretty crazy times we're living in. And then of course, I did mention this a couple times in my talk. This is the cross harness pattern. So don't just use Claude Code. I use Claude Code. I use Codex. I use Cursor CLI. I use different models. Like I like to use Grok 4.5 for simpler tasks. Often a UI change, I use Grok 4.5 because it's fast and it's cheap. For the more complex plans, I use Claude Code Fable. For some work in between, maybe you'll use 5.6 Sol, right? I would say that learn all these different harnesses because they all have their strengths and they all have their weaknesses. Some models are extremely slow. Like I don't want to wait 30 minutes for Claude Code to make a UI change. I would rather kick that off into Composer 2.5 or Grok 4.5 because it's going to run much faster and I don't have to sit there waiting for so long to verify the results. And then also this can be done by like an adversarial review. You can have one agent review the output of others. You can tie them all together in a giant chain. Just very, very important to kind of understand where the models shine and the cost analysis of them. Some models are extremely expensive. Fable 5, I've used over like $200 with one prompt before with Fable 5 API tokens. So you need to keep that in mind unless you're using subscriptions, which I was at the time. Some people are not able to use subscriptions. They're at work. They're using API costs. Some of these models and harnesses are just not possible for them to use. So definitely keep that in mind as you're going through. And then finally, the scoreboard. Okay, so where does the adoption of all these tools actually stand? Maybe you're currently all in on agentic coding. Maybe you're not. But from the research that I found, it says that a share of shipped code written by AI is 22%. For a medium company, for Microsoft, it's about 20 to 30%. From Google, it's 30%. And for most startups, they're saying it's 95%. Okay, so a lot of startups are basically letting AI write all the code. The bigger the company you're at, the more legacy code there is, the more red tape and process there is in place, where you can't just let these agents run autonomously, right? You do have to be a human in the loop verifying this stuff because the systems can get very complex, and not having a human there to review this stuff is kind of scary when you drop production or you break production and now millions of users can't use the app because the AI just did something that you could have caught, right? Now this graph over here is basically saying that people who are using AI are doing about 60% more pull requests per week. Now, I don't think the analytics around pull requests and commits are very useful. You can have one developer is doing 100 commits a day because they make their commits very small and isolated, versus one developer could do one commit a day, but they have 50 file changes in their commit, okay? So some of these stats are kind of silly, honestly, but I would agree that the people using AI are moving much faster, okay? I feel much faster. I move much faster. I can work on many different projects concurrently using AI. And then at the very end, we have some sources of all the information that I found to basically make this article. So yeah, if you guys like this talk, let me know, leave a comment below, and I can make more videos like this in the future if you guys are interested. Have a good day and happy prompting.